Good afternoon, everybody. Welcome to the first storage session of week 2. Apologies for a slightly late start. That's purely down to me having finger trouble with Zoom. Just wait a second because there's still one person waiting to join. Okay, a little bit of admin. If you wish to ask questions, then please use the chat room to ask questions, and we'll make sure that they get wrapped up at the end. I think that's all we need to cover. So with that, we'll move into the presentation. This was probably the first presentation that I accepted when people volunteered lists of presentations, because I personally think it fulfills a need, which is that we hear a lot about object storage, but somehow nobody seems to have told the general storage community exactly what object storage is and how it differs from traditional storage. So we've had a number of sessions already on object storage, and I think this one will help everybody to understand just exactly what the differences are and how they can be used. So let's crack on with that. Ofer Baruch is the Vice President of Field Engineering for Model 9, who are based in Israel. They've, I think, first came to GSE a couple of years ago, and they have some, certainly based on what we saw from early presentations, there's some very, very interesting stuff. So let's crack on.
Hello everyone, my name is Ofer Baruch, I work at Model 9, and I'm going to drive this object storage guide for mainframer session today. Now my main goal in this presentation is to give you guys some more knowledge about object storage and help you do that while comparing with other terminology that you're familiar with the mainframe world. Now, another thing I want to do is try and burst a few bubbles about object storage and cloud storage that you might already have in your mind. So let's dive right in. I'm going to go over the following subjects. We're going to cover what is object storage, the terminology that I've discussed. We're going to go over object storage performance, connectivity, how disaster recovery is done with object storage, and a little bit about object storage security. So the first thing I want you guys to understand about object storage, it is just another form of storage. On the mainframe, we're used to DASD storage, we're used for tape storage. On the open systems, we're familiar with file type storages like NFS, CIFS, and block storage like SCSI, iSCSI, etc. Now, object storage is really a cost-effective technology. It is very suitable for backups and archives, for disaster recovery, but also for analytics, machine learning, BI applications, really anything on that area as well. The key benefits is, first of all, this is an enterprise-grade storage system. Okay, it is fully highly available. It is built for scale and very high throughputs. When in the cloud, infinite capacity, infinite performance, and it is really built for that. The ability to keep scaling by adding more and more hardware into the system. It has built-in security, and we'll discuss that. And it's accessible through standard TCP/IP networking. No FICONs, no proprietary networking needed. Object storage is available both on-premise and in the cloud, right? There are the cloud providers, there are many ISV providers that sell object storage, and we're going to cover a few of those as well. And I think one of the most important features, it is very cost effective. A lot of competition in that area, which reduces the cost dramatically. Now, a few object storage systems out there obviously all the cloud providers, whether it's IBM, Amazon, Microsoft, Google, all have cloud storage, which is object storage. But also all our mainframe ISVs like Dell, Hitachi, and again IBM provides on-premise object storage. Now, the nice thing about object storage is it opens up the possibility for new vendors that we haven't been able to work with in the past in the mainframe area. For example, companies like Scality, NetApp, Cohesity, and many others are now part of this game, and you can purchase object storage from new vendors that are now competing over this market. It is important to understand all the object storage provides some basic functionality that is true really for all of them. There are two main ways to access object storage. There's the S3 protocol created by Amazon. It is the most common one. It is used by almost all the storage vendors. There's also Azure Blob, which was created by Microsoft and really only used by Microsoft Azure Cloud. But again, this is just the API. They're all over TCP/IP, can be accessed from far away. You just need to use the right protocol when talking to them. There are other protocols for object storage, such as Swift. We won't talk about that too much today, but we're going to focus on S3 mainly. Now, I am going to use both Amazon, Azure, and other examples in this presentation. I'm not going to pick on any one specific, but S3 is going to be the main protocol we're going to be discussing. So let's dive into the terminology a little bit. Now, the basic term object in object storage is really the equivalent of a file or a dataset on DASD in the mainframe systems. Now, an object can contain both data, metadata, and user metadata. So this is a little bit similar to a dataset, right? It has the data inside it. It has some metadata like create date, reference date, all these kind of things. But it also contains user metadata that the person writing this object or the application writing this object can include his own metadata inside the object. An object is also known as blob. You will see that name changing from different sites you're going to read about object storage and maybe even in this presentation. Now, objects are stored inside something called a bucket. And a bucket is really a virtual container. You can compare it to a DASD volume if you want. And really, this is where objects and their metadata are stored in. There are many definitions you can do on a bucket, such as what is the default encryption, whether or not you want any specific object storage feature, if you want to replicate a bucket. All of these kind of things are bucket level operations. Now, an object storage system, whether on the cloud or on premises, can host many buckets, right? Buckets are a virtual thing. They can spread on multiple hardwares, which is very important. And vendors use very different names for buckets. Some of them call them containers, some namespaces, some they call them views. So it really depends on the storage system you're talking about. But I think container and bucket are like a universal thing. If you'll ask your storage vendor about a bucket, he'll know what you're talking about, whether it's called in his system a namespace, a view, or anything else. Another important and interesting thing is that bucket names are unique when created in the cloud. So if you're working on an object storage system on Amazon, for example, your bucket name will need to be unique across the globe. This is why, for example, Model 9 usually uses buckets with a Model 9 prefix to make sure we are the only ones using this prefix. But anyone can create buckets with whatever name they want, even with Model 9 prefix or anything else. Now, the bucket name is not limited to a small amount of characters, so this does not become a problem. But just to be aware, it is unique when talking about cloud storage. Now, another important term is availability zones and regions. AWS, for example, has many regions in Europe, and a region is really a physical location that contains multiple availability zones interconnected with special communications created by Amazon. And each one of these availability zones is a physical site. It's fully redundant. It's isolated from all the other sites and has fast interconnectivity between the other availability zones. So you cannot pinpoint where an availability zone is. It is always inside a region. For example, Europe West 1 is a region that has 3 availability zones, each one at a different physical site. You cannot pinpoint where exactly each one of those availability zones are, but they are physically distanced from one another and isolated. So there are many regions out there, not just in Europe, in the US, in South Africa, really all over the world. AWS and all the other cloud providers are creating more and more regions of their own and more availability zones. For example, when you create an object storage bucket on AWS, it will automatically spread all of your data across 3 availability zones synchronously. It's gonna make sure everything is highly redundant, and it's gonna make sure the data is available for you whenever you need it, even if one of these availability zones is down. You can always keep accessing your data. You do not need to know in which availability zone is it. It's always there. You just need to ask for it. Now let's drill down a little bit into a deeper comparison. Now, it is very important for me to say the next slides are not intended to say mainframe datasets or mainframe volumes are good or worse than object storage. It is not the point of this presentation. I will try to use the mainframe terms and the object storage terms in order to compare them, so you'll have a better idea of what is the equivalent term in the mainframe, and we will discuss the differences between them. So for example, an object storage file system is non-hierarchical, very much like the mainframe, right? Although you can put slashes, just like directories, in object names, there are not really directories. There is no directory structure in object storage. In fact, that slash, that delimiter, can be whatever you want in order to emulate directory structure. Now on mainframe datasets, we have something similar. We're using the dot character in order to distinguish between qualifiers. But every dataset is a full dataset name. The qualifiers are not really directories, although we use them in such a way that it'll be easier to navigate. Same thing is true about objects. We usually use slashes. We can use other delimiters if we want. It behaves exactly the same. Now, the size of a dataset is limited by a lot of things like the DSN type and other DASD volume characteristics. On object storage, an object size maximum is about 5 terabytes. And that's it. It does not depend on anything else. You can always create a 5 terabyte file on object storage. Now, the scalability on the mainframe is limited by things like the size of the DASD, the number of data sets is limited by the VTOC size, by the VTOC index, by the VVDS, maybe by the catalog. So it is limited by different factors, and larger sizes cause usually degradation in performance, right? You want to use a very large data set that can degrade your performance. On object storage, it doesn't work that way simply. There's no directories, there's no volume, and objects can span multiple hardware devices, just like a bucket. And there's no physical or performance limits or degradation when using high number of objects or larger objects. Now, this is obviously very dependent on the object storage provider you're using, and these things change between one or the other. But if we take the cloud providers such as AWS or Azure, this is promised by them to be basically limitless, right? You can create as many as you want. You will not be degraded by performance, and they are making sure to add more hardware and do whatever it takes to make sure their cloud object storage performs the same way, even if you keep adding more and more objects. Now, the naming conventions for datasets. Datasets are limited to 44 characters. Object storage is limited to 1024 characters. You can see examples of a dataset name versus an object name. We discussed about the limiters, which can be a dot in mainframe for qualifiers. On object storage, usually slash, but can be anything else as well. Now, all the metadata on the mainframe is kept in the VTalk, in the VVDS, in the catalog, different databases keeping all that data. And we kind of need to, as a system programmer, to take care of that synchronization. A lot of the time it goes out of sync. Now, object storage also have this standard metadata, like in a key value manner. For example, a creation date will be available as standard metadata, but you can also create your own key values metadata. So, for example, the author of a document, the sysplex that you wrote this object from, and a lot of others, really whatever you want. It's limited in Ks, so you can write a pretty large amounts of metadata inside an object, which is very useful a lot of the time. Now, the mainframe is using the VTalk index and catalog indexes in order to provide some fast search capabilities. In object storage, indexing is automatic. This is not something you need to manage. You create objects, they're there, and everything happens really behind the scenes, and you do not need to be aware of those. Now, another nice thing is, just like dataset are stored and filtered by prefixes, so does object storage. So for example, if you try to list everything in your system with the last qualifier of jobs, creating that kind of listing will take a long time, right? The mainframe is indexing by dataset name prefixes and not suffixes. So if you put such a suffix, the mainframe will really have to scan all the datasets in order to find what's ending with jobs. But if you search for a prefix, then the mainframe has an index for that, whether by the catalog or the VTalk, and it's going to fetch that listing very, very efficiently and fast. Now, really the same thing happens on object storage. You can very easily list prefixes and then maybe filter that prefix by something else. But if you try listing everything that ends with txt, that is going to be a very long list, scanning all the objects and filtering them in order to be able to find those objects. Another important thing is modifiability. The content of a dataset can be modified multiple times. Well, this is dependent if it has an expiration date or not, a retention period. But basically, in object storage, objects cannot be modified. When an object is created, it can then be replaced or can be deleted. You cannot update an object. Now, versioning in object storage is a feature used to maintain all versions. So if you create an object and then you delete it, the old version will be kept as a hidden version that you can access later. And if you replace an object, again, the previous version is going to be kept and you can access it later if you want to. Now, I think the last important things, datasets, mainframe datasets, whether on DASD or on tape, can only be accessed natively using Ficon protocols. Object storage, on the other hand, can be accessed via the S3 or Azure Blob or any other protocol over TCP/IP. Now, ZOS does not support that natively and requires additional software layer to access object storage. So let's discuss buckets. Now, comparing a bucket to a DASD volume, it's not a real fair comparison. And as I said, I'm just going to use that as something that will help us get better familiar with the object storage terminology. So as a volume is limited to 6 characters, an object storage bucket can be 63 characters. And this is important, as I said, because in the cloud, this bucket name is unique. So you really need those characters to make sure there's enough bucket names in the world everyone can use. It is common to use your organization name as the prefix, but you're not forced to do that. Now, capacity of a bucket is unlimited. There is no virtual limit to a bucket size. If you have an on-premise bucket, an on-premise object storage, you're obviously limited by the amount of spinning disks you already have attached to this object storage. You can always add more, but you are bounded to the physical amount of storage you have on-prem. When you're in the cloud, obviously, bucket size is unlimited, and you can keep writing to it as much as you want. AWS or Azure or any other object storage cloud provider is going to make sure that storage will never run out. Now, on the volume side, on the other hand, is limited by the DASD model like Model 9, Model 54, etc. Now, the mainframe is using storage group in order to overcome that and have multiple DASD volumes. But you're still limited by the number of data sets because of the VTOC index, and VVDS, the catalog, and all the other factors out there. Now, from a scale, for example, a DASD volume, you can only have 64K volumes on a system, but on object storage, you can pretty much have an unlimited number of buckets can be used. As I mentioned, you have 63 characters. I don't know what numbers that reaches, but really an unlimited number of buckets. Both mainframe and object storage has tiering. So usually mainframe tier to on-premises tape. Sometimes on the DASD storage themselves, they have device types and different RPMs of spinning disk that you can move data from. And object storage is sometimes a tier for mainframes as well. Now, an object storage bucket has multiple storage classes. So a storage class, to not be confused with the SMS construct of a storage class, also allows for tiering. There are different types, like a standard tier, infrequent access tier, glacier tier. They all have different properties, and we'll go over those a little bit later. Now, the AWS command line interface is using S3 in order to communicate with object storage. You can use the AWS command line interface to basically interact with any S3 compatible object storage. You can use Microsoft Azure command line interface in order to use Azure Blob, which is a different CLI, a different interface, but basically provides more or less the same functionality. Now, the AWS CLI will allow you to list, read, write, and do all the different things you can do with object storage. It can be downloaded directly from the AWS website. It is supported on all the platforms and not officially supported for ZOS and Z-Linux. Now, I have seen AWS command line interface installed on Z-Linux and works. It does require some more work, but not really on ZOS. As I mentioned, other product software such as Model 9 allows you to work with S3 object storage directly from ZOS. Now I want to show you a few things that can be done with the AWS command line interface. Now, the first thing you need to do with the AWS command line interface is to configure it. You can get your credentials, your key, and secret. We'll discuss a little bit more about that later. I can specify the region name I want to work with and the output format of the command line interface. Now, the first thing I want to do is I'm going to list with the S3 API all the buckets that this user has access to. So I'm just going to do an ls. You can see a list of buckets that I have on my AWS account. Now I can keep going and drill down into a specific bucket. I'm going to use S3 Model 9 test demo. If I list that, I'll see all the directories underneath this bucket. Now, as I mentioned, directories are not a real thing, but the AWS command line interface will use / as default in order to list things as if they were directories. So let's list a specific file. Now inside this temp directory, I have a file called demofile.txt. Let's copy this file from object storage back into my PC. So again, I'm going to use the AWS S3 interface, but this time I'm going to use a cp command to copy, and I'm going to put this folder, I'm going to say demo file txt, and I'm going to copy it to my local file system. I'm going to call it demo gse txt. Now the AWS command line interface downloaded this file back into my PC. If I'll go ahead and cut the output of it, you'll see the data inside this file just says GSE UK DOMA object. So the command line interface has different commands. You can copy things from your PC to your object storage, from the object storage back to the PC, create metadata, do all the kind of things that we've discussed earlier. And I'm going to let you guys drill down into that offline using the AWS command line interface documentation available at the AWS site. So the next thing I want to discuss is object storage performance. Now, object storage is suitable for very small and very large organization. It is really scalable by design. It is also known as cloud scalability. You can keep adding more and more hardware into an object storage to make it faster, to make it more highly available if you want, and things like that. Usually, the more you read and write in parallel, the more throughput you get. This is kind of similar to when you try and read and write from DASD and tape. If you try and read one dataset from tape, it's going to be relatively slow. If you're going to try and read many datasets from many tapes in parallel, you get a high throughput. Now, the same goes in cloud. The more reads you do in parallel, the more throughput you get. And this is also overcoming things like latency. The more you read in parallel, the faster performance you can get. Now, in the cloud, performance is monitored automatically by your cloud provider, and they will keep throwing hardware at that system in order to keep sustaining the throughput you guys are expecting. On-premise, of course, the storage administrator will need to monitor that and make sure the storage system keeps providing the throughput you want. Now, I do want to drill a little bit more into latency, because that can really vary dramatically when using on-premise storage versus cloud storage. For example, tape storage is almost always on premises with about, like a 1 millisecond response time. Now, if you'll put that object storage on premise, you will get that same latency, as it will just be very close to your mainframe. Now, when working with cloud object storage, this could go to 30 milliseconds, can go even higher, depending of how far away you are from object storage. Now, public cloud by nature has a higher latency because they are farther away from your organization, but also at a fair distance, which the latency is not too high and can provide very high performance. Now, latency issues are simply avoided by using high parallelism and high TCP/IP send-receive buffers. This really allows to get high performance, but this is something that either the application or the human being trying to work with object storage need to take care of in order to make sure you get high performance to the cloud. I'll give you an example. If we take a simple DFDSS job, trying to read a dataset from DASD and sending it to tape, with zero latency, it still has to read that data from DASD, which is very fast, but it will have to push that data into tape in a very serial manner, right? One block after the other. This is when latency becomes key. The farther away that tape system is going to be, the longer it's going to take to send those blocks into the tape system. And performance is very limited when working with a single tape. Now, when working with object storage, you definitely don't want to work the same way because you can have high latency and you will get bad performance if you just try and write those blocks one after the other into an object storage. Now, what you want to do is when you read data from DASD, as I mentioned, that is usually very fast and almost never the bottleneck. You want to accumulate those blocks, and instead of writing them to the cloud one after the other, what Model 9 does, for example, it takes a chunk of those blocks. So instead of, K-sized blocks, we're sending megabyte-sized objects into the object storage. Now, we can have multiple of those objects created in parallel and sent in parallel to the object storage. So even though we're trying to send a single data set into the cloud, we can actually use multiple sessions writing this data out to the cloud. Now, you can compress that data on the mainframe before you send it to the object storage. You can encrypt that data before you send it out to the object storage. All of that will happen in parallel, which will allow you a very high throughput, even to a cloud object storage, and actually faster than a single tape write you might experience on premise. Now, obviously, when reading multiple data sets from DASD, writing multiple chunks to object storage, compressing and encrypting them in parallel on the mainframe, you actually use full parallelism all the way, maximizing your throughput, maximizing your DASD throughput, maximizing your CPUs, compressing using ZEDC cards, encrypting using crypto cards, or all on the zip engines. All of that together allows you to write very fast to any object storage, even if it's on the cloud and obviously if it's on premise. So low latency, high latency, really it all goes away once you start using high parallelism. Now, another important thing to do when working with object storage, it is a single storage and many LPARs can write to it in parallel. When we write, for example, to an object storage, we actually distribute all the backup work across all the different LPARs, all the different KECs, and they all write to the object storage in parallel. So you can keep scaling, adding more resources to your mainframes, adding more mainframes, keep pushing data faster and faster to any object storage out there. Now, a nice scalability example is this activity summary. It actually shows a full volume dump policy backing up to public cloud in this case, backing up 733 volumes out there to the cloud. You can see the actual used size was about 7.8 terabyte. It was compressed down to about 1.3 terabytes using ZEDC compression. The ratio is about 6:1. You can also see the actual throughput of this backup was about 1.5 gigabytes per second. Now, because the data was already compressed on the mainframe using the ZEDC capabilities, the network data that needs to be sent was actually only 270 megabytes per second. So we actually reduced the amount of data that needs to be sent out the wire and sent out to the cloud provider. Now you can see this policy that backed up all these volumes took about 1.5 hours, backing up those 7.8 terabytes. But we then did the exact same policy running on 2 LPARs. So double the resources, more memory, more zip engines available, more ZEDCs for compression, for encryption, and you can see the performance more than doubled. Now this time, the same policy, same amount of volume, same amount of data that needs to be sent to the cloud, reached 3.6 gigabytes per second. Now after compression, same amount of compression because it's really the same data being sent over, we had to send 640 megabytes per second over the wire to the cloud provider. Now this time, this policy ended in 36 minutes. So really, the more data you send in parallel, the more resources you have on the mainframe, the faster you can push data to even cloud providers, right? Now, the same is true when trying to read from object storage. If you would have tried to read from a single tape volume back into the mainframe, again, you have to read that blocks serially from the tape. On object storage, it works a little bit differently. There's no reason to read back the data one block after the other. In fact, we read the blocks in parallel. So those 5 megabytes objects that we send to the cloud, we can now read them back in parallel to a read-ahead mechanism to read as many as we can back into memory, uncompress them in parallel, unencrypt them in parallel, and send them back writing to DASD. Now, this is true if you recover multiple data sets in parallel. Obviously, you're still having multiple objects being recovered from the cloud and multiple objects being written to DASD in parallel as well. So another important factor in object storage performance is tiering. As I mentioned, this is known as storage class. This is not the SMS construct of a storage class. And it pretty much says everything you need about performance and redundancy. So for example, the standard tier is a high performance and cost. It is the highest cost storage tier. And it will provide you the best performance. Standard IA has the same performance as standard and is intended for infrequent access. This is usually what you will use for secondary storage on object storage, so backups, archives. It will still provide you that great performance, but it will cost a lot less than the standard tier. Now, one zone infrequent access is again a high performance, but also lower redundancy. If you remember, we talked about availability zones. By default, data is kept on 3 availability zones. So you get very high redundancy of your data. In one zone IA, you get your data in a one physical availability zone. It will still have redundancy inside that availability zone, but if that availability zone goes down, your data is not available anymore until that availability zone comes back up. Now the next tier is Glacier. This is for long retention. It is a cold storage. It has very high recovery time that is not measured in milliseconds or seconds. Recovering something from Glacier is a matter of minutes or hours, depending on how much you're willing to pay to recover your data. So if this tier is used, it's usually used for something you know you need to keep for many years, and the chances you're gonna try and get that data back is low. Now, another tier that is available on many object storages is automatic tiering or intelligent tiering, which will automatically move the data between the different tiers, trying to reduce the cost while still providing you good performance. Now, on-premise object storage can also tier from faster to slower drives. Some of them can tier to tape, and some of them tier to cloud. This is actually very common. You might have an object storage on premises. All your short retention data will be kept on the object storage, and anything that has a long retention, you can tier off to cloud object storage. So how do you connect to an object storage? Well, if it's an object storage on premise, your standard LAN network and firewalls will come to play, allowing you to access your object storage through standard TCP/IP via the OSA cards. When talking about cloud, you would usually want to have private access to your cloud storage, private IP addresses not accessible from the internet. You can have AWS policies and firewalls as well to make sure and maintain security. But in order to do that, you need one of these two, either a physical connection between your site and AWS, also known as a Connect Direct, or you will need an encrypted site-to-site VPN that will connect your on-premise network to the cloud network over the internet. Now, another option for cloud access is public access. So public IP addresses still have AWS policies, firewalls, credentials, all these kind of things to secure your data, including encryption and all the things, but it is connected via the internet. So some customers use this, some customers use that. It really depends on your organization's security standards. Disaster recovery with object storage is really simple. If you talk about cloud providers, object storage uses regions and availability zones to make sure you have your data across physical sites. So all that redundancy you kind of get for free. Data is synchronously spread on the cloud providers with a minimum of 3 availability zones. It's using a protection known as erasure coding. If you're familiar with all different RAID possibilities for data protection, erasure coding is something a little bit different. I'm going to let you guys drill into that a little bit on your own. And the nice thing about cloud providers, you can recover your data pretty much for anywhere in the world with network connectivity, right? If you know the credentials to your storage and you have a network connectivity to the cloud provider, you can access your data. So in a DR site, you just need to make sure you have a connection to that public provider, whether over the internet or via a connection which is physical, and you can access your data from the DR. Now, when we're talking about on-premise object storage, different vendors provide synchronous or asynchronous replication, also supports erasure coding, not just RAIDs, and also have active access solutions for simplified DR. So some vendors actually allow your bucket to be available for read-write in 2 different physical locations. So when you start your mainframe on the DR side, you really don't need to do anything. You don't need to fail over. You don't need to do anything complicated. Just need to point your mainframe to the DR object storage and you're good to go. The data is available there for writing. If you write on the DR, it's going to automatically replicate to the other site. So both systems are active. Well, not all systems are like that. So sometimes you do need to replicate depending on the object storage you selected, and you might need to fail over and still point your mainframe to the DR object storage. It does require some more planning and hardware infrastructure than cloud providers, where cloud providers simply do all of that automatically for you, even if they're failing availability zones, etc. One more thing just to notice, it is possible also to replicate across multiple sites. Both object storage solution, you can replicate, 4 sites, 6 sites, really as many as you want. And same goes for cloud providers. You can replicate across multiple regions. So from the west to the east to the north, wherever you want. So you can have multiple copies, even in different regions. Now, this is an example architecture for a DR site with Microsoft Azure. You can see you have your primary site, you can have your DR site, which might be passive. All of them has physical connectivity out there to the cloud. And on normal days, you're simply writing and reading from your Azure Blob storage out there in the public cloud. And when you fail over to the DR site, you simply keep doing that with the same object storage in the cloud as if nothing changed. So a lot less work to do when starting up a DR site and a lot less thing to manage. Object storage security is another important matter. User management, for example, there are 2 ways to access object storage, either programmatically or using standard web console access. You can access buckets, objects, different actions. So a specific user might have access only to a limited bucket names, only to limited object names, limited actions. You can give a user read-only access to a bucket. You can give user read and write. The different types of operations, for example, putting an object, deleting an object, listing, deleting an object versioning, if you have versioning enabled for a bucket. And this is kind of similar to a RACF profiles. So really you say what resource you want to protect. So bucket/object name pattern, what kind of class you want. So maybe putting, deleting, listing the different access this user can have and which user has which access. So kind of similar approach. You can also use patterns. You can use even source IPs. You can control who can access your buckets in many different ways. That can cover everything you need in that manner. Now, object storage also supports encryption in flight and encryption at rest. For encryption in flight, really we're talking about standard HTTPS using TLS or whatever TLS version is currently the most updated one. If permitted, it is possible to use HTTP. Sometimes if you're working on premise and you do not encrypt your data on premise, you can avoid encrypting. This will free up some more resources from your mainframe as it will not have to do all the encryption work. But there's also data at rest encryption. It is managed by the object storage itself. It can be managed by user managed keys or by object storage keys provided by the cloud providers. So the data can be always encrypted, whether it's in flight or at rest on the disk's systems. Now, humans actually access object storage using the console or the command line interface. A product will obviously use the programmatic credentials in order to access object storage. Now, as a mainframe user, you will not really be accessing the object storage directly, right? The software you have installed, for example, Model 9, will need access to the object storage. It will do all the listing, the writing, the reading to the object storage. The mainframe side security is going to be used to protect mainframe resources and mainframe users. So a product wanting to use object storage will still use the SAF interfaces to protect your users, whether it's RACF, CA Top Secret, or any other security product you might have on the mainframe. And it will verify, authenticate your user. It will authorize the user if it has access to a backup, to a data set, to anything like that. So a mainframe user really need RACF access to the resources, and the software layer accessing the object storage is the one permitted to the object storage. So the object storage software will only access the object storage on your behalf if you have the appropriate RACF permissions to access that data. So a quick summary about object storage. It is available on-premise and in the cloud. You can purchase whatever you want. There are many ISVs out there, new players that you can talk to and look around their object storage solution. It is an enterprise level storage with high redundancy, high performance, really scalable. It supports different types of replication, including security, encryption at rest, encryption at flight. It is very suitable for replacing or extending your mainframe secondary storage, sometimes replacing it completely, sometimes having an extra copy on object storage, maybe on a cloud. Maybe you want an air gap solution. You can use that as well for an extra copy of your data in the cloud. And it actually simplifies disaster recovery dramatically. Thank you guys for listening. If you have any questions, feel free to add them here and I will try to answer them all.
Okay, thank you very much. So I'll just open the session for questions now. So if you wish, you can unmute yourself and ask a question. I haven't noticed any questions in the chat window. So let's see if there's anything that anybody wants to come up with now. Whilst you're considering whether or not you have a question to ask, can I remind you that we'd be grateful if you completed your session feedback. I've dropped a link in the Zoom chat that helps us, helps the speaker, and as a small incentive, there's a session feedback prize which you might win if you put feedback in. You certainly won't win if you don't. If you if you have a requirement for proof of continuing personal education, then you can get that from the MyGSE part of the conference website if you need that. Okay, any questions?
Either everything was very clear or was very not clear. So
Well, I would say it's very clear, actually, Offer. So that's probably why you're not getting any questions. Wait a few more seconds for people to ask a question, and if not, then the only thing that remains is for me to thank you very much for the presentation. I think it's covered personally, it's covered a lot of questions that I had about the use of object storage in a mainframe environment and what object storage is actually doing. Okay, it does look like we're not getting any questions. So again, thank you very much, Offer. And yeah, I'll close the session. Thanks again, Offer.
thank you guys. Have a great day.